Hello. This lesson is about inequalities, and we've got a few other things in there, but the key thing we have in this lesson is solving inequalities. So I'm just going to start off by saying, when you solve inequalities, if you multiply or divide by a negative number, then that's when you need to flip the symbol. Okay, that inequality symbol of greater than or less than, greater than equal to, less than or equal to. If you multiply or divide by negative, that's when you've got to flip the symbol. Okay, so we're also looking at solutions of these inequalities. So before we go into the solutions, we're going to write and practice intervals notation and set notation a few times. So -8 to 3 means that our x cannot get bigger than 3. So this is the same thing as saying that x must be less than 3. Now notice that when this is pointing to the left, which makes sense as far as from 3 to the left. But to get it in full set notation, you put a little bar up in front of it. And we also have braces. So now that reads the set of all x such that x is less than 3. Now in this next one, x has to be greater than -4. However, it can also be equal to it. That's what that bracket means. So we're going to have x's that are greater than or equal to -4. And you put that little straight line with the brace. And that means the set of all x such that x is greater than or equal to -4. When you take interval notations, you have 2 of them, then you just put that within one brace. So this is the set of all x such that, and then we look at each one of these and do it. So this first one is x is less than 4, or x is greater than or equal to 7. So we're either to the left of 4 or to the right of 7, but we could include 7. Now what about when we have set notation, we want to go back to interval notation? Well, the easiest way to read this one is x is between. But really, if you think about it, we've got 2 sections of it. We've got x is greater than or equal to -5, and x is less than 8. But interval notation is the easiest way to do that one for sure. It starts at -5. It goes to 8. It can include -5, so that one is a bracket, but it cannot include 8, so that one's parentheses. So now, as we go and we take these exact same interval notations, so the next slide's going to have the same stuff that's written on the left. We can put those on the number line. And I'm going to do that, but first of all, I'm just going to put some numbers on the number line. It's just a little bit more efficient for me. The only number, I'm going to put numbers on there like we see over here. So there's a 3 that needs to go somewhere on this one. Now don't get hung up about that's not, 0 should be in the middle, because there's no middle to a number line actually. It goes forever both directions. I need to get a -4 on the next one. The next one has a 4 and a 7, so somewhere there's a 4, 5, 6, 7. And then our next one has from -5 to 8, and the only way to do that on this number line is probably to count by 2s. So I am going to stick a 0, 2, 4, 6, 8. And that's, again, I counted by 2s. So -2, -4, -6. So I'll use that spot right in the middle there for -5. Okay, so here at -3, it's open at -3 and headed to the left. So we're going to have that parentheses, and then we're going to head to the left. And we know I can never draw the straight lines looking at this little black pad with no lines on them. If I draw them fast, they're like way uphill or way downhill. From -4, it heads to the right, but it does include -4, so that one is a bracket. and it heads to the right. The next one is 2 sections. It's not in between them. It is from the 4 to the left with the parentheses at 4. And it's from a 7 to the right with the bracket at 7, meaning it can include 7. And then our last one is between -5 all the way to 8, but it does include -5, so that one's a bracket. It does not include 8, so that's parentheses. And it's in between, just like that. Now that's particularly important to us then in this lesson, because what they're going to give you is instructions like you are seeing right on this second little set here: solve, graph, write the solution set in both interval and set notation. So we have all of those to get done. So as I solve, if I subtract 6 from both sides, I have 2x is greater than 4. X is greater than 2. Now, I didn't divide by negative. It's only if you multiply or divide by negative you need to flip that inequality. Okay, so to graph that, somewhere on this number line there's a 2, and I am headed to the right of 2. I cannot include it, so I get a parenthesis, and then it heads to the right. In interval notation, then it's parentheses 2 to infinity. In set notation, I almost have it here where I finish solving. I can just add that line in front of it for the x, and then my braces. So now I have all of that one done. This next one's just a little bit longer. We'll change color so it doesn't blur together too much in our eyes. I need to distribute -2. So I have -2x plus 20 plus 1 is greater than 0. Those are like terms there, so I'll have -2x plus 21 greater than 0. -2x is greater than -21, and now I need to divide by negative. So the moment you divide by negative, you also need to flip that inequality. So that's going to be 21 over 2, which is a little bit awkward to try to put on my number line. So that's the same thing as 10.5. So x has to be less than 10.5. So if I just say, okay, well, somewhere there's a 10. That doesn't even look like a 10, but somewhere there's a 10 and then there's an 11. 10.5 is in between there. I cannot include it because it's a strict inequality. And I need to head to the left. Ah! You just gotta laugh. Okay, so what is the solution in interval notation? It's always open at negative at your infinity. So it's coming from the left at -infinity, and it goes all the way up to 10.5, and it does not include it. That's interval notation. In set notation, I can go back down here where I said x is less than 10.5 and just add that bar in front of it so that I can get my actual set notation around it. That's supposed to be an x. Okay, so x is this. Oh, I can't even stand that. That looks so terrible. Let me try that x again. Surely I can do better than that. There we go. The set of all x such that x is less than 10.5. So this is really, we write it kind of like domain because the x's that are okay to use are the x that are used. Either way, it's all kind of referred to that. So we have the domain in interval notation and set notation, and that is the solution to our inequality. But sometimes we end up with double inequalities. And just because we have 2 inequalities doesn't mean they both work well. Okay, so we could still have a no solution, or we could have infinitely many solutions. That can happen. You just have to work them out. But know that if it's and, your final answer has to be between, or it has to be true for both of them. Okay, for both of them. So I'm going to solve them individually, and then we'll look at where they both are on a graph and choose our answer. So here I have 3x is less than 12. Divide by 3, x is less than 4. Moving to my next one, I have 2x is greater than 16. So x is greater than 8. So my numbers are 4 and 8. So let's look at where they would be on a number line. 4, 5, 6, 7, 8. Again, I'm just sticking them on there so we can talk about it. For each of them, I'm going to highlight that. X is less than 4 would be over here. X is greater than 8 would be over here. But this is supposed to be an and. Can you be to the left of 4 and to the right of 8? No, you cannot. So there is no solution for this one. Okay, that is not the answer. There's just no solution. Because you cannot do both. And has to be true for both of them. So if I needed to write that in set notation, just in case, that would be the empty set, which is the same thing as that 0 with the slash through it, right? And we don't ever write that in interval notation, just truth of the matter. All right, so now let's look at our next one. If you've written it in between, what you want to do is solve both sections or all 3 sections of that at once. So I'm going to add 3, but I'm going to add it to all 3 parts of that. So -5 plus 3 is 2. It's supposed to be less than or equal to. Then I have a negative x. Add 3 to that part, that goes away. And then I have less than or equal to 2 plus 3 is 5. So now I need to divide all 3 parts of that by -1 to take care of this negative, that's understood one that's in front of the x. But when you divide by negative, that's when you flip the inequality. So when I divide by -1, I get -2 is greater than or equal to. Then I'm going to divide by -1 and I get x is greater than or equal to. Divide by -1. So all the inequalities flipped because I divided by the negative. So now looking at where that is on my number line, somewhere there's a -2 and a -5. So -5, 4, 3, 2. Now we'll look at them with a highlight and see where they are each. What this is saying is x is in between. It is bigger than -5 and is less than -2. And you can be both of those places at once. So we can definitely have an answer there. It is a closed interval because they both have an or equal to. Okay, so interval notation goes from -5, always start with the smallest one, to -2. And then I want to write set notation. I could put the arrow in front of that. I mean, put my line in front of that and finish it out. But typically, we always do the smallest numbers first. So I'm going to rewrite that one. So we have the set of all x such that -5 is less than or equal to x, which is less than or equal to -2. So notice if you're trying to rewrite it, just make sure you center up the arrows in the same direction. This had the open end towards -2, and I still have the open end towards -2. I had the small end towards the -5. I still have a small end towards the -5. Okay? So that one does have an answer, and we've written it in both ways. All right, now let's look at these 2 situations. They're both or problems. And so for an or, it does not have to be true for both of them, but simply one of them. So as I solve this, if I add 3 to both sides, I'll have 4x is less than 4. Divide both sides by 4, and I get x is less than 1. Now here, if I add 1 to both sides, I have 2x is less than -6. Divide both sides by 2, and I have x is less than -3. So putting these numbers somewhere on the number line, I would have like -3, -2, -1, 0, and 1. And so if I were going to look at the solutions individually, we would be from the 1 and to the left, and at -3 and to the left. But since this only has to be true for one of them or the other one, I get to put them together and use the largest region of that. So actually the solution simplifies just to say that x has to be less than -1, because everything to the left of -1 is true for one of them or the other. So then in interval notation, I would have from -infinity to 1, open on both of those. And really, for set notation, I only need to illustrate this one in set notation. So it's the set of all x such that x is less than 1. And what happens is that this one is just kind of included in the previous answer. All right, one more of these. Now this one is set up to be where it looks like this is between, okay? So I'm just going to go ahead and solve this like we would typically. If I subtracted 5 from both, well, really not both, but all 3 of these sections of this, 13 minus 5 is 8. And if I subtract 5 from the center section, that one goes away, and 5 minus 5 here is 0. Now divide all 3 sections by 8, and I get 1 is less than x, which is less than 0, because 0 divided by 8 is 0. So what you see here is that x seems to be between 0 and 1, and that makes sense. But if you look at this carefully, again, it says 1 is less than x, so that's like saying x is greater than 1, and then x is less than 0. You cannot be, if you had a 0 and a 1, and you considered that, this says x is less than 0, x is greater than 1, and this one, because it's written in between, is an and. It's an automatic and when it's written in between. 1 is less than x, and x is less than 0. So if we went to the left of 0 and to the right of 1, I can realize what areas of the graph I'm talking about, but can you be in both of those locations? You cannot be to the left of 0 and be to the right of 1. Okay, so x cannot be in between 0 and 1 with the arrows pointing the directions that they have been given. So in this case, this is another one that is a no solution. And again, the real thing is because this, when you write them in between, it automatically means it's an and situation, and we can't be both of those places at once. In a savings account, at the beginning of summer, he wants to have at least $200 at the end of summer. He withdraws $25 per week for food, clothing, and movie tickets. How many weeks? All right. How many weeks is going to be the variable? That's what it's asking. So I'm going to use W. You could use X. You can use anything you want to. But we have $500 to withdraw is to take out, and he's going to take out $25 every one of those weeks. So when you hear that per, what you're dealing with right in front of that is a slope. It was $25 per week, so the slope was 25, or -25. Withdraw 25 per week, -25 week. Okay, and he wants to have at least 200. That's a greater than or equal to, because it's going to be okay with him if he has more. So this is our inequality, and we just had to set it up from reading the problems, and we've got to solve this. Subtract 500 just from both sides. -25W is greater than or equal to 300. Divide both sides by -25. Because you are going to divide by negative, you have to flip that inequality. And so we will get 300. And it'll go in there 12 times. And what I'm hesitating on is I know that this should come out to a positive 12, but it sounds like it's going to be a negative, so what is wrong? Oh, right here, I should have had a negative 300. I knew something was wrong there. Okay, so this would mean at most 12 weeks. Less than or equal to 12 weeks is the same as at most 12 weeks. Time can't be negative. I knew there was a mistake. Watch for the things like per or each, though, for you to find your slopes. Okay, key information. We've got 3 shirts. Each was the same price. Okay, each of the same price. Less than, that's my inequality, $12. Change from a $50 bill. Okay, he starts with $50. Because he's buying shirts, he's spending money, that amount's going to go down. Each of the shirts was the same price, so that 3 is my slope. And the price, you can put a P here, we can put an S for shirt, but what is the maximum cost of one shirt? I'm going to put an S for shirt, and he ends up with less than $12. All right, so we want to solve this. I'm pretty sure that should say minimum, because it could cost more than we're going to get, and he'll just end up with less money. I know that should say minimum. Let's just change that right now. So if I subtract 50 from both sides, negative 3S is less than negative 38. So S, I'm dividing by negative though. So dividing by negative means I have to flip that inequality. I'm going to divide by negative 3. So negative 38 divided by negative 3. And I'm going to go ahead and round that off to the nearest penny. It came out to 12.6666666666. You know what I'm saying? So that's 12.67. So the shirts cost a minimum of $12.67. At $12.66, he gets just over $12 back. At $12.67, he's going to get just under it. But like if they cost $12.68, he would still have less than $12 and change. That's why I know that that's the minimum there. So the minimum cost of the shirt is $12.67. All right, so that's our application problems. Now a couple of homework tips for you. Anytime it says X represents the number of years past something, and it might not be 2004, but I do think I copied that from a homework problem, then you just have to know that if it asks you something about when X equals, or excuse me, when it's 2010, what that tells you is that you need to let X equal 6, because you just have to subtract those, because X is the number of years after it, okay? So whenever you have a problem like that, expect to have to subtract the years so that you can figure out what X is. Some of the application problems deal with flat fees and a rate. When you see a rate, what you should think of is slope, and I've already mentioned that. But so if somebody's going to charge, and this is a very realistic application, a service call fee plus an hourly rate. You call someone to fix your heater, they might say, I'm going to have to charge you at least $45 to come out there, and then $30 an hour for however long it takes. That's what is happening there. So if you were doing a service call and an hourly rate, your fee that you were having to charge, that's kind of like your Y, would equal the service call plus the rate times the number of hours they were out there. For base salary and commission, your overall salary is equal to your base salary plus your commission plus a percentage of your sales. So a long time ago, you know, I worked in retail and I'd get a base salary, but then I'd also earn a percentage of what I sold, but I didn't earn it on everything I sold. In my case, it was this next issue. It was a base salary plus commission after a minimum, which means my salary was a base plus my percentage, but instead of just multiplying it times the sales, it had to be the sales minus the minimum. Okay, so those are some things that might help you set up some of the word problems that you need to work. Now, one last slide is just a reminder of things we've recently gone over. A correspondence is a function if every element in the domain X, or your input, has to go to the range, which is Y, or the output. There are two cases for limiting domain. First case, a denominator cannot equal 0. And the second case is the radicand of an even root can't be negative. So where you kind of find those is if you have a fraction and you have a numerator over a denominator, then what you know is that that denominator cannot be 0. And in our second case, if you have an even root, it's probably a square root, but it wouldn't have to be. It could be a fourth root. Whatever is underneath that root is called the radicand. And so you would have to take, well, whatever that is, then must be greater than or equal to 0 and find the domain. I don't know why range is on here, but we've already mentioned the ranges are Y value. Okay, now parent functions are the simplest functions of their type. So a parent linear function, a linear function would be like y equals mx plus b. The simplest function that we could write like that is y equals x. And that is the identity function, and I believe they mentioned the identity function in a homework problem, and I don't know that we had clarified what that is, but this means whatever you put in, you get out. That sounds like real life. You put in a 2, you get out a 2. You put in -7, you get out a -7. That is both the parent linear function and the identity function. All right, and that finishes up this lesson.